Hi guys! If I asked you all, what foods are examples of carbohydrates? What would be your answer? There are a lot, such as rice, bread, potatoes, sugar, and fruit. What if I were to change the question a little and ask, what kind of substance is carbohydrate? We eat it all the time, but it is difficult to answer this question, isn't it? I will now explain what carbohydrates are and the properties you should know about them, so you will be able to answer this question perfectly. On that note, let's get started. First of all, let's think about what sugar is. To begin with, a sugar is a carbon compound with an aldehyde or ketone group and a hydroxyl group. That's not very clear. Roughly speaking, a sugar is a molecule made up of carbon, oxygen, and hydrogen. Since it is made up of carbon and water, it is also called a carbohydrate. So that's what carbohydrate means. Now, there are many kinds of such sugars. The most famous sugar is glucose, which flows through our blood vessels. Glucose is an important source of energy for the body. Another sugar you may be familiar with is fructose, which is found in fruit. The fru in fructose comes from the word fruit. There are also other sugars such as galactose and ribulose. Incidentally, as you may have already noticed, the names of sugars end with ose. That means that substance that makes up DNA is also a type of sugar. Yes, I am talking about deoxyribose. It turns out that sugar is a very important substance for us living organisms. Well, now that we're starting to grasp the concept of sugars, let's move on to what the relationship is between these sugars and the carbohydrates we mentioned earlier, like rice and sugar. In fact, these sugar molecules have an interesting feature that provides a clue. The molecules can form bonds with each other, as if they are joining hands. These bonds are called glycosidic bonds. Let's play around with the glucose molecules here a little bit. When two glucose molecules bond with each other, they form a substance called maltose. If we join more glucose molecules, we make what's known as dextrin. Make it even longer, and it forms starch. The main component of foods like rice and bread is starch. Essentially, these carbohydrate-based foods are made up of long chains of glucose molecules. Some of you might be thinking, I knew that already. Now, let's play around with a different type of sugar molecule. If we join a glucose molecule with a fructose molecule, it forms a substance called sucrose. You might be surprised to know that sucrose is what's commonly referred to as white table sugar. If instead of fructose, it's galactose bonding with glucose, it forms lactose, which is abundant in breast milk and cow's milk. By the way, the molecule we saw made up of one each of glucose, fructose, and galactose is called raffinose. These may look different, but since they're all made up of sugars, they're all carbohydrates. They vary in the types of sugars they're composed of, the length of the chains they form, resulting in different appearances, tastes, and properties of carbohydrate foods. However, in reality, there are many more carbohydrates in existence. And when there are so many types, human nature drives us to categorize them. That's why we've come to categorize them roughly based on the number of sugar molecules they're composed of. When there's just one sugar molecule present, it's called monosaccharide. And when there are two sugar molecules like in white table sugar, it's called disaccharide. When there are more, they're referred to as oligosaccharides. And when there are many sugar molecules linked together like in starch, they're called polysaccharides. Now, we consume carbohydrates, as explained earlier, every day in order to live. However, there's one significant problem. In fact, humans can only effectively absorb monosaccharides. But rice and bread contain starch, which is a polysaccharide. What do we do? The key players here are digestive enzymes. Digestive enzymes break the bonds between sugars, breaking starches down into smaller pieces which are easier to absorb. On the other hand, with monosaccharides or disaccharides, this process is very quick or even necessary, isn't it? Consequently, the time it takes from being consumed to being absorbed is very short. In other words, blood sugar levels are more likely to rise rapidly. The reason why consuming excessive amounts of glucose, fructose, sucrose, found in juices and sweets, is considered harmful is because of this. Conversely, when experiencing low blood sugar levels, consuming these sugars helps lead to a rapid recovery. On the contrary, there are also polysaccharides that humans cannot break down. For example, cellulose. Cellulose is a polysaccharide found abundantly in plants. It might be easier to picture cellulose if you think of dietary fiber or cotton wool. Surprisingly, cellulose is also made from glucose. However, unlike starch, it is bonded together through a different method called beta bonds, and cannot be broken down by the digestive enzymes found in humans. These polysaccharides, which cannot be broken down in this way, cannot be utilized as energy no matter how much sugar they contain. This is the reason why dietary fiber is considered zero-calorie. However, herbivores like cows have an enzyme called cellulase, which means they can digest it. That's why they can survive on grass, which is full of cellulose, by turning it into fuel. However, among traditional Japanese foods, there is one native indigestible polysaccharides called konnyaku. No matter how much you eat, it cannot be broken down or absorbed, so it's 0 calories. It's quite a strange food, isn't it? Speaking of carbohydrates, do you know how much energy they provide? There's something called the Atwater system, which indicates how much energy carbohydrates, proteins, and lipids produce. According to this system, carbohydrates are said to yield 4 kilocalories per gram. I'll introduce proteins and fats in more detail in the upcoming videos. Let's summarize what we've learned so far. Feel free to pause the video and have a go at filling in the blanks yourself. There are various types of sugars. The main ones are glucose, fructose, and galactose. Sugar molecules can link together through glycosidic bonds. A single sugar molecule is called a monosaccharide. A molecule made up of 2 sugars linked together is called a disaccharide. Up to around 10 sugars. An oligosaccharide. And even more than 10. A polysaccharide. In order to absorb carbohydrates, humans break them down into monosaccharides using digestive enzymes. There are some polysaccharides which humans cannot digest, like dietary fiber. Okay, that's all for now. In the upcoming videos, let's take a closer look at proteins. See you later!